everyone, Dave Norris here. I'm a MuleSoft developer advocate, and in this video tutorial, we're going to be covering off how you can publish and subscribe to an event store like Apache Kafka to participate in event-driven architectures. And I've split the tutorial into three parts. In the first part, we're going to be talking about setting up an Apache Kafka cluster running on Heroku. And as part of that setup, we'll be setting up three topics to send messages into, one called raw stream, one called split one, and one called split two. In the second part of the tutorial, we'll be moving on to creating a Mule application that drives the integration flow. And as part of that Mule application, we're going to set up a message listener to subscribe to events coming into the raw stream topic. And we're going to do some basic processing to inspect the payload of those messages. And based on a number in the payload, we will send them either to the topic called split one, if the payload value is less than or equal to 5, or into split two, if it was anything else. And in the third part of the tutorial, we'll be testing the application. So we're going to use the CLI to send a message into raw stream, and we'll be tailing the logs for split one and split two to see the messages arrive and if our Mule application functions correctly. So without further ado, let's get on to part one, the setup of Heroku Apache Kafka. So the first thing we need to do is create an application to run on. I'm going to call mine Mule Kafka, but it's important to note that the name has to be unique. So if you get an error here, then change the name to something that's unique to you and replace the value as we go through the commands with the application name that you've picked. So once we have an Heroku application running, we can then specify that we want to create an add-on. So in this case, we're going to create an add-on called Heroku Kafka, and we're going to select a plan. We've selected the basic 0 plan, which is the cheapest plan to set up a Heroku Kafka cluster, and we're going to attach it to our application. Now, this process typically takes about 10 minutes. So in order to check the creation status, you can run Heroku add-ons info, just specifying your Heroku application name. And what you'll see when you run that command, right at the bottom, you'll see the current status. So currently it says creating. Let me come back after it says created and we'll continue the tutorial. So about a 10-minute wait. Okay, so as you can see, I left it for about 4 minutes. We queried the status, and now you can see that the state is created, so we're ready to proceed with the next step. So one thing we need to do, since we want to listen or subscribe to events coming from a topic that we're going to create, we need to create what Kafka calls a consumer group. And a consumer group is really a group of consumers, I bet you didn't see that coming, that will subscribe to a topic, and Kafka will make sure that that event is only ever pushed to one of the consumers sharing the same consumer group ID. So using Heroku Kafka consumer groups create, we can then give it a name. I've just called it Mule Group. Feel free to change it, and the application name. So we'll be using this in our Mule application to subscribe to specific topics. So that's now being created successfully. We can then move on to creating topics. Now remember, in the setup, we had 3 topics. Raw stream, which is just going to be receiving events, and then 2 topics where we will be fanning out the payload into. So Kafka topics create, and then we just specify the name of the topic we want to create, the partition we want it, how many partitions we want, and the application to attach to. So we'll do that for a raw stream. We'll create one for split one. And the third topic that we've creatively called split two. Now, later on in the tutorial, there are a couple of variables that we're going to have to remember. And the best way to get those is getting the config variables we need. And we need two at this stage. One called Kafka URL. So since we've created the Apache Kafka cluster, we need the Amazon EC2 URLs that we can use to connect to our cluster. So by getting the Kafka URL, we can see here we got a string. I can paste this and I'll save it for later. So I've called these Kafka URLs. The only other one we need is one called Kafka prefix. So one of the consequences of choosing the basic plan is that it's a multi-tenant Kafka cluster. So my consumer group and my topic names are going to be prefixed with something that's unique to me, but I'll be sharing the infrastructure potentially with other customers. So to get the prefix I need to use to connect to my topics, I need to get the Kafka prefix. And again, we'll save this variable for later. Okay, so we've now got an Apache Kafka cluster running on Heroku. We are now going to play around with the certificates and keys because we're going to have to create a key store and trust store that we can use in our Mule application to connect using SSL. All connections to Heroku Kafka support SSL encryption, and there are 3 variables I need to get from the Heroku server in order to set up a key store and trust store for my Mule application to use. So I'll use the Heroku CLI to download the broker's SSL certificate and save it in a file locally. Then I'll download the Kafka client certificate. And finally, the client certificate key. So if you've run this correctly, you'll see that you'll have 3 files: Kafka cert, Kafka key, and Kafka trusted cert. So MuleSoft supports many different types of key stores. For this tutorial, we're going to use the industry standard PKCS12 format for the key store and JKS for the trust store. So we're going to use OpenSSL first to combine the Heroku Kafka certificate and the Heroku Kafka client certificate key into a PKCS12 file. It's going to get us to specify a password, which we need in the next step. What we should see now is a Kafka cert PKCS12 file. So now we're ready to create our key store, and we're going to use this in our Mule app for the SSL connection. So by using the key tool utility, I can create a key store called keystore.p12, and it's going to get me to specify a password. So I'll use MuleSoft KS or key store. And make sure that the destination store type is PKCS12. So it's going to get me to enter the password from the previous step. And if it's completed successfully, we should now see a key store file. To create a trust store and add the broker SSL certificate that we downloaded from Heroku, we first need to convert it into a binary format, which is what the trust store expects. So we'll use OpenSSL to do that. And again, we created a file called cert.der, which should now be present. And then we just simply need to import that and specify the trust store file that we want to create. We'll use a password of MuleSoft TS, or trust store for short. It's going to ask if I trust this certificate. I'll type in yes. And at the end of these instructions, what you should end up with is a key store, which is in PKCS12 format, and a trust store, which is in JKS format. Okay, let's briefly recap on where we're up to. So in the first part of the tutorial, we've just created our Heroku Apache Kafka cluster. We configured 3 topics, and we've also now got a key store and trust store in order to establish an SSL connection from a client application that we're now going to create. So we're going to focus now on the second part of the tutorial, which is creating the Mule application. Now, in terms of the variables, let's just briefly recap what we've got. We've got Kafka URLs, we've got the Kafka prefix, and based on our SSL configuration, we now have a key store password, which we use MuleSoft KS, and a trust store password, MuleSoft TS. So we're now ready to create our Mule application. So we can open Anypoint Studio and click Create a Mule project. And we'll call this Kafka Connector. So the first thing we're going to do is set up the foundation of our project, which, if you've been following the Getting Started series of tutorials, you'll know is creating a file where I can share connector configuration information. We'll call it global.xml. It'll seem trivial in this tutorial, but as your Mule integration flows get more complicated, having one place where you can share this information across many different flows will help you in the future. The other thing we're going to need under source main resources is a file that follows the best practices on externalizing some of the variables we're going to need. So local.secure.yaml is going to hold the information we need to establish a connection to our Kafka cluster. And you can see that the values I have here, you can see where they come from now. Because if I move back to our notepad, we can now start copying in some of this information, like the server URLs. And we can now copy in our consumer group, which we called Mule group. The topic we want to subscribe to is going to be raw-stream. And now we just need to specify a value for our key store password and trust store password. So the reason we store it in this secure YAML file is because what we actually want to do is encrypt these values. Because anything I'm putting into this properties file is available in plain text in an XML file that I'll potentially be checking in and out of version control. So that's the next step. We're going to use a utility to encrypt the values. So on a command prompt, we're going to use the secure properties tool jar file, and the link's available in the tutorial. And what this allows us to do is to say we want to encrypt a string using an encryption algorithm called Blowfish. We're going to give it an encryption key. We've picked MuleSoft !123, and then the value we want to encrypt. Now, MuleSoft KS is actually our key store password. So by using this encryption algorithm, I'm going to get a string that I can then copy and paste back into my YAML file. So I can now repeat that for my trust store password. And I've now secured potentially sensitive information. Okay, so the other thing we're going to do is copy in our key store and trust store to our project. So in the package explorer on the left hand side under source main resources, I'm just going to paste in two files we created previously, the keystore.p12 and the truststore.jks. So we're now ready to set up how our Mule application is going to read this file and decrypt the key store password and trust store password. In order to do that, we are going to add the secure properties configuration module to our project by heading to the global XML file we have open and searching in Exchange for that module. So I'll use the search string secure and it will appear at the top. Mule secure configuration property. Add it to my project. It will appear in the palette as secure properties. And that gives me access to, if I click on global elements and create a new element, I can now see under connector configuration, secure properties config. And really what this is asking me is, what's the file that has the encrypted values and what's the key I should use to decrypt those values? So I could type in local.secure.yaml, but we talked about the fact that different environments are going to have different values. So I'll make sure that there's a variable called env so that I can set that to either local, which will read the file we currently have, or in the future sets me up to create additional files for dev, test, and prod. Same with the encryption key. I don't really want to store it in plain text. Then anyone would be able to unencrypt this file, so we'll use a variable we can set at runtime. The only other change I have to make here is the algorithm we use to encrypt the values was Blowfish. So I've now told my application how I can read that file to decrypt the values, and that sets us up to now add under the Kafka connector, we can add the Apache Kafka connector from App Exchange. Add that to our project. And you can see here it gets added to the palette, and we'll be using message listener and publish. Now what I'll do is I'll set up the connector configuration so it knows how to connect to my Heroku Kafka instance right now before I add anything into my canvas. So I head back to global.xml and we'll click create and we'll search for Kafka, and we're going to get two connector configurations, one for the consumer when I want to subscribe to a topic, and one for a producer when I want to publish to a topic. Now our flow will eventually need both, so we'll set them both up now. You can see it needs Bootstrap server URLs. And now we've set up our secure properties configuration, we can specify a value that looks a little bit like this. So the secure : syntax tells MuleSoft to go and read my secure properties configuration, read the file, and read this value in the file. So it's looking for Heroku Kafka with the property server URLs. So I don't have to type them in. I've already done that in my configuration file. So I can now rinse and repeat. Where's my consumer group? And the topic subscription patterns. We put that in what property called topics. And now I need to hit the security tab. I need to specify the endpoint identification algorithm. It's important you put in a blank string here. And then we can edit the TLS configuration where we specify the trust store, which is the file we dragged under source main resources. The password, again, we've safely encrypted that. So we can just refer to the property. And the type for our trust store was JKS. And then we'll do something very similar for the key store, but the key store was PKCS12. Refer to the key store password, and we're done. So I'm going to rinse and repeat now for the producer. And that's the configuration set up for the Kafka connector. So let's go ahead and start building out an implementation for our flow. To do that, we'll head to the Kafka connector.xml file, and we'll drag in a message listener to our canvas. And you'll notice it automatically picks up the Apache Kafka consumer configuration we've already set up. There's nothing else we have to do because it already knows which topics we're subscribing to. We do need to transform the inbound binary input into JSON. So we'll add a transform message, and we'll simply add some data weave that's going to read the inbound payload and convert it to JSON for us. We'll then add some flow control because we wanted to fan out the message based on a value that's being sent. And the choice flow control lets me do an if-else statement or a when default statement. So if I highlight the when box, I can configure an expression. In this case, we're going to look for a property called split value. And if it's less than or equal to 5, it's going to execute whatever's in this box. And what do we want it to execute? Well, that's going to come from the Apache Kafka connector because we want to publish to another topic. You can see how different the publish operation is to the message listener operation, because now I have access to different properties to set, like which topic am I going to publish to and what's the message that I'm going to send. And we said if the payload was less than or equal to 5, head to a topic called split1, and we'll use the Kafka prefix again. If it's any other value, let's add another publish operation. And send it to a topic called split2. And that is really our integration flow configured, ready to go. The only thing left to do now is to test it. Okay, in order to test the project, we are going to use the command line interface to publish an event to the raw stream topic, and it's going to have a payload with a property called split value. If our Mule application is running successfully, it will subscribe to it, inspect the payload, and decide where to fan that message out to. If the payload split value property is less than or equal to 5, it'll end up in split1, else it will end up in split2, and we'll use log tailing to see what's happening in these topics. So in order to run this, so we can actually test it out, we just right click on the Kafka connector, head to Run As, Run Configurations, double click Mule Applications, select your project and head to the Environment tab. Because if you remember in the Secure Properties configuration, we created 2 environment variables, one corresponding to the file name local.secure.yaml, and one corresponding to the encryption key. So when we encrypted those values, we used MuleSoft ! 123. And then we can hit run, and this takes 2 to 3 minutes to finish. So I'll speed this part up and hopefully see you when it's successfully deployed. Okay, so hopefully you've reached this part where you can see your project's been deployed and you've got no errors, because we're now ready to test it. So the way I've decided to set up the testing is, you can see on the right hand side, I'm tailing the logs of split 1 and split 2 to see the messages that are coming into them. And on the left hand side, we'll actually write a value to the raw stream topic, and we're just going to pass in a simple JSON payload with the property split value. So initially we're going to set this to 3, because if our Mule app's working, anything less than 5 needs to be sent to split 1. And we can see here that the original payloads safely arrived at split 1. And conversely, if we have a payload that's greater than 5, we need it to head to split 2. And there we can see our message has been safely processed and sent to the split 2 topic. And that is it. Cue the confetti. Congratulations on subscribing and publishing to an Apache Kafka cluster. Stay tuned for more tutorials at developer.mulesoft.com.